Natural gas utilities and their customers benefit from accelerated pipeline replacement programs for aged cast iron and steel pipeline infrastructure. However, conventional replacement methods are very costly, and alternative approaches that provide equivalent or better safety and considerable savings with minimal disruption of traffic infrastructure are highly desirable. NYSearch Northeast Gas Association partnered with Cornell University experts in gas pipeline infrastructure testing to test lined cast iron pipe segments that have been in service for more than 10 years to ascertain the long-term operating viability of cured-in-place liners. Public Service Electric and Gas provided a 6-inch diameter main that was lined with the Starline 2000 product in 1998, and this main was operating at inches of water column. The second segment of pipe came from National Grid. They provided 12-inch diameter cast iron main, which was lined with the Starline 2000 product in 2003. And this particular segment operated off of a 60-pound pressure system. We wanted to test a worst-case scenario. So we removed the concrete seal that was above the jute. So this way the joint actually flexed during the cycle testing. The 12-inch joint is a mechanical joint, as you can see here. So this joint will not be able to be weakened prior to its testing and will be tested as it came out of the field. This test setup is measuring the deformation resultant from cycle loading of heavy vehicles, street traffic such as buses and trucks. And it's also measuring deformation that a main could experience from an undermine event, such as an excavation around a pipe and then the subsequent backfilling of that excavation. This 12-inch section of cast iron main is supported on each end by 2 fixed supports. Centrally located on the joint is a hydraulic press, which applies a downward deformation on the joint. The joint itself has deformation measuring devices located at the 12 o'clock and the 6 o'clock position, and the pipe is maintained at 15 pounds pressure to ensure the pressure boundary remains intact. The pipe undergoes 55 years worth of cycle loading, which includes 20,000 cycles a year for 50 years of loading that's indicative of heavy truck traffic and buses. Then it will undergo an undermine event, and then it will be tested for 20,000 cycles a year for 5 more years, totaling 1,100,000 cycles of loading. The pipe segment in this setup is undergoing thermocyclic testing. A piston on this side is pulling the spigot approximately 3/10 of an inch out of the bell to represent a typical freeze cycle. The main will then be put under compression to return it back to its original position, representing a typical thaw cycle. We use these load cells to measure the tension on the pipe segment, and these instruments around the circumference of the pipe are measuring the separation of the joint. After we complete thermal cycle testing in this test setup, the pipe segment will be removed, put back into the deformation setup, will be exposed to an additional 50 years worth of cycle loading, and it will be brought back down to the thermal cycle testing setup for a final 50 years worth of thermal cycle loading. In total, this will simulate over 100 years of field service of a cured-in-place line pipe. After the pipe completes its simulated aging, it'll be observed for debonding of the liner from the host pipe. If we look at this 6-inch pipe sample, we can see there's been some debonding of the liner from the joint area, which would be expected due to the flex during the cycle testing. And then we're going to cut 1-inch wide segments of the lined pipe that has been aged, and then we're going to compare that to the field aged pipe that has not undergone laboratory aging to see if there's any change in the strength of the liner. I'm very satisfied with the level of performance of testing being done here at Cornell on cured-in-place liners, and I'm looking forward to have conclusive results of how cured-in-place liners perform long-term in the field. NYSearch, in conjunction with Con Edison and Progressive Pipeline Management, recently conducted a cured-in-place liner demonstration in Mount Vernon, New York, utilizing the latest standard operating procedure and quality control practices designed to ensure the highest quality installation. In addition, Con Edison has been installing cured-in-place liners on aged cast iron and steel pipelines for over 2 decades with great success. Funding for NYSearch Northeast Gas Association cured-in-place liner research was provided by the Pipeline Hazardous Materials Safety Administration, Con Edison, Public Service Electric and Gas, Philadelphia Electric Company, and National Grid. For more information, please contact NYSearch Northeast Gas Association.